Hello and everyone, my name is Mei Chun, and today I will be talking about the functional and non-functional requirements of my obstacle sensing system, which is this little thing right here. Okay, so first of all, let's talk about the functional requirements of this obstacle sensing system. So the first functional requirement of this system is definitely detect obstacles and provide information about the distance, but very accurately. So how would I say very accurately? So this obstacle sensing system can actually detect obstacles like it should, but the ultrasonic sensor, which here you can see, actually recalculate the distance between itself and the nearest obstacle, which is this metal box that we will be using as an obstacle further on. So it can detect, it can recalculate the distance between itself and the nearest obstacle for every 5 milliseconds. So besides, it could also show very detailed and precise information about the distance with obstacles in cm and mm, which we will talk about it later. So the reason why centimeter and millimeter measurement is used in this system is because it is just for demonstration purpose only, acting as a prototype of the system. So in real life, it should be meter and centimeter. So all of these functions help to prevent unwanted car accidents. So right now I will show you the serial monitor. Okay, serial monitor of my program. So here, as you can see, the output is produced in very quick speed. So here I'm actually moving the obstacle right now, so you can see the distance always change very quickly. Sometimes you would see 1000 plus cm is because my hand accidentally move away. So here you can see it detects the obstacle very quickly, very precise, right? Because it recalculates the distance every 5 milliseconds. Okay, so moving on to the second functional requirement, which is informing drivers about the distance with obstacle through simple indication. So I was first inspired with the beeping alarms in cars that usually beep faster when a car gets nearer to an obstacle while reversing. You know, like beep 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 beep, something like this. So similarly, I have 3 LEDs right here, which you can see, each having different color. So actually they all represent different level of distance with the obstacle. So first one, the red one, actually represents very near distance with the obstacle, ranging from 0 to 10 cm. So here you can see this range is still red, right? After over 10 cm, then here yellow represents the near range distance with the obstacle, which is 11 to 20 cm. And then lastly, green stands for the far range, which is 21 to 30 cm. So this functional requirement is especially very crucial for drivers because they have to focus on many things when they are driving, right? Like for example, there will be suddenly a passerby walking beside your car, or a car went past your car very quickly from your front or something like that. So these simple indicators, right, to like the LED colors, could help the drivers to understand very quickly and distinguish the different range of distance between the car and obstacle at real time. So to avoid the drivers to not focus on driving because of seeing too much information. So here you can see the demo. So this is like the obstacle. This is like the car back bumper. So it is hard to move this, so I would move the obstacle rather. So right now the obstacle is very near. You can see the red LED is always blinking until after 10 cm range, then it will change to the yellow LED that is blinking. Alright, I hope you can see that it is actually blinking. So after the 20 cm range, right, then here goes the green range, which is very far, to represent obstacle. This is the back bumper of the car. Okay, also, right now you might have already find out that my system actually does not have any OLED display. This is because I feel that it is already outdated. So, and also a lot of people has already done it. So instead, I thought of helping the poor people who still drive old cars with no OLED display. So to help them, the system is actually able to connect to other smart devices through Wi-Fi connection. But how? So for instance, this Node MCU in this system, this piece right here, is actually able to connect to a Wi-Fi connection or even a smartphone mobile data connection. So the third functional requirement of the system right here is to provide real-time distance value or information on other smart devices like smartphone and tablets through Wi-Fi connection. So user can actually connect to a URL and URL given from the serial monitor in the Arduino IDE. So through in a browser through their smartphone to obtain like very precise information of distance that is measured in centimeter and millimeter, as the web page will refresh automatically every 5 seconds. So I mean sorry every 5 milliseconds, 5 milliseconds. So users can see accurate real-time information even without the OLED display, right? Because they are poor. Most people are poor and they don't have OLED display in their car. So this function is important because information feedback like this actually helps the user to prevent from car crash. Therefore, I think it is a functional requirement. So I will show the demo later. Okay, so this will be the demonstration for the third functional requirement, which is to provide information through smart devices with the help of Wi-Fi connection. So first of all, you see our system is actually working, our hardware is working. So the first step right now, right, is to obtain the URL which will be produced from the serial monitor. So here we go to our Arduino IDE. You have to go to the serial monitor first. Okay, so you have to open it. Okay, disable auto scroll. So I will click the reset button right now. Okay, so I will reset the whole system to make it connect to my phone again. So this is my phone. So okay, here it shows controller has connected to WLAN. So here's the URL. You see the URL right here. So I have to type in this URL into my phone. Okay, so I will type in right now. http://192.168.165.163. Okay, so this is the URL. As you can see, it's the same right here. So when I enter the URL, here you see some content. Okay, so you see my hand is actually not touching the phone right now, right? So I'm actually moving this obstacle again, so to demonstrate that it provides very accurate information, and the web page is actually refreshing itself automatically every 5 milliseconds. So here you can see the current distance is always changing. It shows cm and mm information according with the word, the range, 3-level range, very near, and far. After it exceeded the 30 cm range, then there will be no obstacle detected nearby. So this functional requirement is actually very good, especially towards the poor, because they don't have money to afford new car with OLED display. So instead they can just use their mobile phone, cheap mobile phone or tablets, and mount them on their car, and then connect this system with their own mobile data connection, because currently I'm using mobile data hotspot, right? You can see mobile data on, Wi-Fi off. So yeah, this is actually a very good replacement for the OLED display. So that's why I don't include OLED display in my system. So let's move on to the non-functional requirement. Right, so now let's talk about the non-functional requirements of this obstacle sensing system. So first of all, this system definitely has the non-functional requirement of great performance quality. So when people talk about performance quality of the system, right, especially in IoT systems, usually they like to compare like how much does the system cost, how effective it is, or how accurate can it perform. So this system is definitely very cheap, which is costing only like RM 46.80 cents, I remember, to build, as I assume everyone has a smartphone, so I don't count the smartphone price in the bills of material, BOM, which you can see right now. Okay, so and this effective system also definitely did all, if not more than, an obstacle sensing system should. Not to mention, with this cheap building price, this system could even be used on smart devices through Wi-Fi connections. And I believe that those expensive obstacle sensing system that is built in the cars could not even do that. So it sure can accurately recalculate the distance every 5 milliseconds and display the info even in very precise measurement like centimeter and millimeter, which you already see from the serial monitor or the browser on the phone demonstrations. So right now you can see how accurate it is. It don't even skip, it don't even pass through the middle yellow light. So moving on, the second non-functional requirement, which is great reliability. So because this system is a very small system, as you can see, just consists of these few pieces of materials. So it has very less components, and therefore I could say that it barely has anything that can fail, or at least this small amount of components help to minimize the failing rate of the system. So because the lesser the components, the lesser problem you will create, right? So I have also ensured the system to be reliable through code. For example, like some error handling when the Wi-Fi connection has error or could not be found, which you can see in the code later. I also protect the hardware of the system. For instance, like right here, as you can see, there's a little cute resistor. Okay, I have installed a 150 ohm resistor for all of these three LEDs right here, so to prevent them from receiving the overpower voltage which then will cause the system failure. So therefore this system is surely to be reliable at any time for the drivers to use. Okay, so besides, the third non-functional requirement should be great maintainability. So the system is also easily maintainable because it is simple. As you can see, it only consists of a little components, a few wires right here, so it's already done. So if there is any failure, right, either the codes or the hardware, even the codes is very simple. So this small amount of codes and simple components could be easily replaced, especially these components. They are very cheap and they are very simple to install. So if there is any issue, it's very easy to maintain. And for the codes, they are very short, so I could search through them very quickly and then fix those easy codes easily. So lastly, the final non-functional requirement should be great availability. So the system definitely already has great reliability and great maintainability, as I explained just now. So with those, the users are able to use this system at any time and anywhere as long as they are driving, no matter what weather condition or anything, any condition. So to prevent them from crashing into obstacles while reversing or maybe even driving, who knows. So yeah, it definitely has great availability. So I think that's all from my explanation for the functional and non-functional requirements.